Hello and welcome to the episode 9 of Code Deep Dive. In this episode, I will be showing how standard optional is designed in C++. If you find presented content useful, don't forget to press the like button and subscribe. I will start by creating optional integer object. I will be showing what happens while checking if value is present and how the value is accessed. Let's deep dive. The object is initialized with value 100 as expected. Optional is a templated class that inherits from optional base and enable copy move. Optional base inherits from optional base imp. Optional base imp contains declaration of storage type, which is basically type that we are declaring with optional constructor call. Second template parameter contains type of implementing class. We will see later that this allows this base class to call itself. Such hierarchy allows separation of operation and data layout. Optional base declares conditionally constructors depending on the type passed. This allows compiler optimization and avoids explosion of methods. Optional base contains reference to payload, which manages actual data. Optional payload is templated based on which type of class it holds, and declares only required amount of trivial constructors or destructor. Optional payload base is a class that finally contains our data. Payload attribute is of type storage, which is union. This union declares two fields. First is empty of empty byte type. Empty type is an empty structure. The second is value of our optional template parameter type. Once we get back, we see there's also enable copy move inheritance, which adds a set of constructors depending on trait properties of our type. Let's put it into diagram for better visibility. Optional is our target type. It inherits directly from optional base and enable copy move. Optional base inherits from optional base imp. Optional base contains optional payload. Optional payload inherits from optional payload base. Optional payload base contains storage. Storage is an union with empty byte structure or our target type. Knowing how things are structured, let's check the flow when checking for the value. Has value checks m is engaged, which is part of optional base imp. This picks payload attribute from inheriting optional base class. Since the value is stored, engaged flag is true, and this is returned value. When calling value, there's a check first for isEngaged flag, and only if true, mget is called. M is engaged, is sanity checked again, and the get is delegated to the optional payload base. Mget picks safely the value directly from the storage object. Mind there are two mpayload fields, one in optional base and the other in optional payload base. The return value is 100, as expected. Let's see what happens when calling reset and then calling value or and value on the object. Effectively, reset is delegated to the payload. Payload checks engaged flag, and if it's set, the value is destroyed. Destroy set engaged to false and calls explicitly destructor on stored object. We call value or on empty object. If engage was set, the value from optional would be returned. Since engage is not set, the passed value is returned. Let's see what happens when obtaining value from empty optional object. When flag is engaged is not set, bad optional access is thrown if exceptions are enabled. When casting optional directly to bool value, casting bool operation is called on optional object, which is checking is engaged flag. Returned value is false as expected. Let's check memory layout for this object. After putting value 100 into optional object, we can see that first 4 bytes contain value 100. The next 4 bytes contain value 1, which hold engaged flag. After object is reset, the 4th byte is reset to 0 as expected. Mind that the object is considered empty, however the old value still remains in memory. In order to demonstrate additional functionality, I will create person class with 2 attributes, non-trivial constructor and destructor. This time, I will create optional person object using makeOptional. Let's deep dive into this one. MakeOptional accepts variable amount of arguments and delegates construction to optional class. There's additional inplace argument, which is an empty tagging structure. Optional constructor invokes base, which is optional base alias. Optional base constructs payload with the passed arguments. For person class, we have optional payload with non-trivial constructor and destructor. Finally, payload of storage type is initialized. Storage is constructed in place by constructing person object at value attribute with passed arguments. Eventually, person constructor is invoked. We can see that value contains person with passed attributes. Also, engaged flag is now set. Finally, once the object is removed from the stack, person destructor is invoked as well. It's invoked by optional payload base destroy, which invokes destructor directly on the value attribute. Destroy is called by reset function. Reset function is called by optional payload destructor itself. The last thing to show is modifying optional that already contains the object. Let's deep dive into emplace method. Firstly, payload is being reset, and as we saw with payload destructor logic, if manage flag is set, destructor on value is called. Once the value is not valid anymore, construct is called with passed arguments. Invocation is delegated to payload. Since value was already initialized in the past, the call will take memory address of the value first. Address retrieval is a new build function. Next, construct is invoked. Construct calls new operator on past value address and invokes person constructor. This was explained in standard allocator video. Additionally, reference to created object is returned. In this video, I showed how optional is implemented in standard C++ library. In the next video, I will show how unique pointer is designed in C++. If you like this video, make sure to press like button and subscribe. I hope my content will help you creating something great. Thanks for watching.